since it's a 3D array representation which we represent in logical manner here, and this is how. So what is the 3D actually? It looks like a cuboid. You can see here cuboid, it is having the 3 dimensions. Your interview as well as in your GATE exam, they will be giving you the name of the array and this dimension like L1 colon U1 comma L2 colon U2 comma L3 colon U3. What all things represent these variables actually? First of all, you are having 3 dimension in the case of the 3D array. So this is the first, second and third, 1, 2 and 3. So for each dimension there is a lower boundary as well as upper boundary. So L and U is there for each dimension. Therefore you can see for this dimension we are having the L1, that is lower boundary, and upper boundary. That means depending upon whether if your indexing is starting from 0. If there are 4 elements, then the lower boundary will be 0, and since there are 4 elements, therefore what will be the upper bound? It will be 3 because you are starting from 0. So if the indexing starts from 1 and there are 4 elements, so lower boundary will be 1 and upper boundary will be 4 since the indexing starts from 1. If the indexing starts from 2 and there are 4 elements, so you can see the lower boundary will be 2, the upper boundary will be 5 because 2, 3, 4 and 5. This is what actually whatever you start your index. So we will take different examples. First we will see how it is represented in the cuboid form and how it is easy to draw the formula. It will be very much interesting as well as easy. Sequentially we will finally draw the formula one by one, step by step, and then we will see how we can modify. In fact, there are changes in the indexing. If it's not starting from 0, it's starting from 1, then what changes will be there in the formula? That is very much easy. So let's start for that. So I hope so you got this. What is this? This is an array and this is the lower boundary for the first dimension. This is the first dimension, this is the second dimension, and this is the third dimension in case of the 3D array. So first dimension we are having 2 things present for that, the lower boundary of this and the upper boundary. So consider if we are starting from index 0, so therefore this will be how much? It will be 0, this upper boundary will be 1, so it is 3. So therefore if we start from 0 actually, this L2 will be 0 and U2 will be 2 because we are giving this size as 3, so therefore 0 to 2. And then in case of this third, that is we are having 2. So this will be L3 and U3. L3, so you will be 0, we are starting from 0, U3 will be 1. So you will be given with this question actually in case of the 3D array. You will be given L1, U1, L2, U2, L3, U3. You will understand actually how many elements are present. So how to calculate the number of elements? Suppose I am given with this 0 and 1. So you can see here if I am given 0 and 2. So how to calculate this dimensions? Actually it is simple. So this upper boundary minus lower boundary plus 1 will be giving you total number of elements. Upper boundary minus lower boundary plus 1. So therefore upper boundary for this is 1, this is 1, minus lower boundary this is 0 and plus 1. So therefore total how many elements are present? 2. You can see here 2 elements are there. So we have calculated this dimension for that. And for this again the same formula if you do, that is 2 minus 0 plus 1. So this will be equal to 3. So you are having total 3. If it is like this, then this will be 1 minus 0 plus 1. So it will be total 2. You can see here 2. So this is how you can calculate number of the elements which are there, and you can calculate the size of the 3D array. Yeah. So now let us see actually how to draw the formula using the row major order. Now first of all, you can see here I have taken this cuboid of the sizes. You can see this is U1. This one is the U1 which I am given this dimension. Since we are having the size, U1 is what? As I told you now itself, U1, U represents the upper bound of the dimension. So U1 will be the upper bound of the first dimension, U2 will be upper bound of the second dimension, U3 will be upper bound of the third dimension. You say that we have to represent it, we have to calculate the address using the row major, that is the row wise we have to represent it. So let's cut actually this cuboid row wise. Let's cut into different slices. So when you cut this total cuboid row wise, that is horizontally, so how it will be there? It will be like this. Here I have cut into 1 row, I have cut into 2 row, I have cut into 3 row, I have cut into the 4th row. 5 row and so on, depending what is the size. Now you can see since it's a row major order, therefore I'm cutting it into the row wise. Row wise means horizontally you are cutting, right? So if you cut actually this whole slice, you will get one slice. So you'll get different slices. So if you represent into different small sizes when you cut this cuboid in this manner. So how many slices first of all you can make actually if you cut it horizontally? We have cut it into horizontally. How many slices I can make? I can make the size of U1, because you can see this is one slice, this is 2 slices, this is 3. So depending upon how much is the U1 actually. U1 is what? Upper boundary. How many elements are there? How much value is there actually? What is the length of this? That much number of slices you can cut it. So I have cut this total cuboid horizontally, that is row order wise in this format. That is this one, I got 1 slice. This again I'm getting the second slice, I'm getting the third slice. In this manner I'm getting the fourth slice. If you cut actually like this, you will get 1 slice of this. You will get 1 slice, you get 1 slice. So how much number of slices I can create depending upon the size, that is U1. So depending upon the size of the U1, you can understand that much number of slices you will get. So therefore this will be 1, this will be 2, this will be 3 and till U1. Suppose we are considering the indexing starting for all the dimensions from 1 and not from 0. So therefore 1, 2, 3 till U1 I am able to get these number of slices when I cut this total cuboid. So therefore your L1 we are considering, L2, L3 we are considering 1 and not 0. Let us see actually if we are knowing the address of this element. So what is the address of this element? The address of this element, it is first of all the first element in your entire 3D array, and we know that what is the base address. We know the base address, it is what? It is the address of the first element of the array. Whatever array it is, if it's a 2D array, 3D array or 1D array, the address of the first element will be the base address. So this is your element actually, which I am representing by dot, and address of that will give me the base address. So since we have to find the address of any element in your 3D array, so we know we are having the array first of all, and how to get the base address? Simply we know that by giving the name A actually, we will get the base address of the element. It represents the address of the first element. So that is the thing. So we will be simply given in this manner in the array form, and A will give us the base address. So now how we will get the address of this element? So we know first of all the base address, right? And we have to calculate the address of this element. So we know that first of all this is 1 slice, this is 2 slice, 3 slice and till U1. The base address of A1, 1 and 1. So this is first of all A1, A1, right? So I have to calculate the address of this. How I will get the address of this? That is, this will be present. So this is present here. That is, I have to calculate here like this. I have to calculate the address of. First of all, I am starting the indexing not from 0. I am starting from 1 actually. Therefore, you can see the first element is present at the index 1, 1, 1. It's a 3D array, not 0, 0, 0. We are taking from 1. Therefore, I have taken like that. So therefore, this element will be having the index 2 and this 1 and 1. This will be the index of this. I have to calculate the address of this element. How I will get? So first of all, we know to reach to this element, I have to first cross the whole 2D array, which is of the dimension that is U2 into U3. After crossing this whole U2 into U3, that is the 2D array, then I can get this address of this element, because after crossing this whole element 1, 2, 3, 4, 5, 6 whole element till this, the next actually I can get the address of this. So that means how much I have to traverse? I have to cross the whole 2D array of the dimension U2 into U3. It will be simply equal to the base address plus, we know the base address, plus the whole U2 into U3. I hope so you got this. This is what? This is A, 2, 1 and 1. This element is. So address of this will be simply the base address plus the whole U2 into U3, right? Now if I have to calculate the address of A3, 1 and 1. If I have to calculate the address of this, then what will be the changes in that case? So to reach to this element, actually I have to cross first this 2D array and then I have to cross this 2D array. So two 2D arrays I have to cross, then only I can reach to this element. So therefore A of 3, this is what? A of 3, 1, 1. So to get the address of this element, again it will be equal to base address, that is this base address plus 2 into U2 into U3. So 2 U2 U3 I have to cross 2D array. How you can then change the formula now? How? So therefore we are considering this as I, because we are starting actually as this is I, the element which you have to find the address of. So the first dimension is I, second dimension is J, and third dimension we are considering as K. So therefore this is U1 actually. Therefore I am taking it, the dimension I am taking the name as I. So therefore to calculate the address in case of the, so I have to calculate the address of, in that case, I, like this. What changes I can do? Now here I means what? So we have seen to calculate the address of 2, 1, 1, 1, 3, 1, 1 we got. Now if we have to calculate the address of I, 1, 1, so we know that what will be the changes? It will be like this, base address plus, here it will be I minus 1 U2 into U3. So why I am taking this I minus 1? So we know that when we have to find the 2 actually, then in that case this was simply 1. So when it was 3 actually here, this became as 2, right? So now I am taking this as I. So therefore it will become 1 value lesser than that. Therefore it is I minus 1, because for 3 it is coming 2. So for I we have to cross I minus 1 total U2 into U3. So I hope so you got actually till this point actually. Now let's consider, let's enlarge this small 2D array into bigger size, and let's see into detail now. Now if I extend this whole this actually as a bigger size in this manner, yeah. So this I am extending actually, this is my U2, U3, yeah, and this I which I am extending this whole into bigger size. Know the address of this, we got it like this. Now we have to calculate the address of this element, this one. How much we have to cross? You can see to reach to from this element to this element actually, we have to cross the whole this row actually. So this row is of the size U3. You can see this whole row is of the size U3. This is of the size U3. So you have to cross total U3 in order to reach to this element. So U3 is having so many elements present in it, and after crossing all these elements, then you can get the address of this element. So then what will be the change in that case? So address of A, this is as it is. Now we have to reach to this element. So its dimension, this will be changed, because this represents actually your U2. So this is what actually the whole sizes of U2. So therefore this represents U2, and therefore I told you, since we are representing the this is J, we are representing by the variable J. So therefore this I am changing actually from 1 to 2 to reach to this element, and this is same, that is 1. So to reach to this element actually this one, then it will be simply I have to cross the whole U3. So whatever formula you got, we have to add this U3 in order to get the address of this element. So I have modified this second value from 1 to 2, because I have to reach to from this to this. So therefore from 1 to 2 I have modified. Therefore it will be the base address U3, and then you can see here I will simply add here the U3, because I have to cross the whole U3, the first row, in order to reach to this element. So many elements I have to cross. So how I am traversing? Row wise I am traversing, therefore it's a row major order. So now we got the address of this element, right? So if I want the address of this element, then in that case again what will happen, again I have to add, to get the address of this element, I have to cross this whole one row as well as this total 2 row, and that is of the size 2, it will be of the size u3, so 2 u3 it will be. So to get the address of a, I and then 3 and 1 will be the base plus 2 u3, because to reach to this we have to cross 2 rows and that is of the size u3. Okay, so therefore the change will be address of a. Now this one is, first of all, the u2 is representing j and this u3 is representing k. We are taking that index. So therefore if this will be, I am taking this now j and this is now same as it is. So since we are having that we have to calculate the address of the element row wise actually, therefore I have taken now j, this whole is j. So therefore it will be the base address plus I minus 1 u2 into u3 and plus j minus 1 u3. So why I have taken j minus 1? Because when it is 2, this is 2, this is my j value. When this is 2, you can see here only 1 u3 I have to cross. When this becomes 3, then I have to cross only 2 u3. So when it is j, therefore I have to cross j minus 1, because we have to subtract from 1. We are seeing from 3 we are getting 2, from 2 we are getting 1. Therefore from j we will get j minus 1. So till we have reached till j we have seen for j. Now if we have to calculate the address of this element. So in this manner what we will do, if we have to calculate the address of this element, we have to simply add only 1 to this whole expression. So to reach to this element, let me write here, I am not having the space. So to reach to this element, the total expression plus 1 it will be. So therefore a of I j, and here I have to calculate this one 2. I am changing from third dimension, I am changing from 1 to 2 because I have to calculate the address of this element. So I have to calculate the address of this element is equal to the whole expression plus 1. So therefore base address is 1 u3 plus 1. So I have changed this expression by adding only 1 if I have to reach to this element. So if I have to reach to this element, in that case, that is this one, if I have to reach, in that case I have to add one more value, that is I have to add 2. So 2, that is address of a, I, j, and this is 3. So that will be simply base address. Yeah. So you can see here too. So we know that first of all this u3 which is there, it represents k actually. So therefore let me just change it here itself. To calculate the address of array of I, j, and then finally k, equal to simply the base address we have seen plus we have seen what it is, and then plus k minus 1. So now why I have written here, why I have modified the formula to this actually k minus 1 here. So we have seen actually here itself that in order to reach to this element actually, that is if you can see here, I have written here like this, a, I, j and 2, this is 2. So to reach to this element, that is 2 here, therefore we have to simply add 1 here, right? So if we have to simply calculate the address of this, that is this element, I have to add 2 to it. So therefore you can see here, if it is 3, I have to add 2 to it. If it is 2, I have to add only 1 to it. Therefore if it is k actually, therefore I have to add only k minus 1 element in it. So this is how you got overall your formula whenever you have to calculate the address of the element in case of the 3D array using the row major order. So this is, I hope so you got it. It is very much interesting, as well as we have seen one by one. We have divided the whole cuboid into different slices. We have cut it into in this manner. We have cut it in this manner. We got so many slices, and how many slices we can create, it depends upon the size of U1. Therefore, this is 1 slice, 2 slice, and this is 3 slice till U1. And we have seen that each slice is of dimension, that is U2, U3, U2, U3, like that. And therein we have seen, if we know the address, we know that we are having the base address, we can calculate it's the address of the first element. So therefore we can get address of this element. We have seen we have to cross this whole 2D array. So we keeps on adding 2D array to it. Now we have enlarged one 2D array, and we have seen how we can find the address of this element. For that we have to also add this one row. How to calculate the address of this? We have to add one more row. Then from that, how to reach to this element? We have to add 1 and 2 and 3 respectively. And finally, we are getting the address whenever we have to calculate the address of any element. This will be the formula: base address plus I minus 1 U2 into U3. U2, U3, U1, all these are the dimension upper boundaries of your array, depending whether here I am taking from the indexing from 1. It can happen that you are asked to, you are given and started with the index from 0. You are started, the question is starting from the index minus 1. Or it is 1, if it is 2, if it is 3. So no problem, you can accordingly simply substitute your values. You can calculate the lower boundary and upper boundary. I have told you, if we are having total 4 elements and if the indexing starts from 0, then lower boundary will be 0, upper boundary will be 3. If your total number of elements are 4 only and indexing is from 1, so then how much it will be? Lower boundary will be 1, upper boundary will be 4. And if your indexing starts from 2, so from 2 till 5, 2 will be lower boundary and 5 will be the upper boundary. So that you can calculate. And number of elements is how much actually in the dimension upper boundary minus lower boundary plus 1, that we have seen. So now let's take one problem actually and use this same formula in order to calculate the address. So in that manner we will understand it much better. We will use the same formula and we will see, we will calculate the address of that element, and we will see whether in the memory representation we have seen how it is represented. We can tally actually the address of that element which we got from the formula, and the one in linear form, in the linear representation, what is the address of that element. So if it is same, that means we can ensure yes, this is our correct formula. So let me just write a problem. So this question will be asked in the GATE exam or in your interview for the 3D array, that this is your dimension and you have to calculate the address of this element using the row major order in the 3D array. So then what will be the solution, how you will solve it? Let's see that next.